Most AI models like ChatGPT give you text. They wait for a prompt and they type out an answer. But an AI agent is different. It's a system designed to interact with external tools and APIs, translating natural language intent into real-world actions. By the end of this video, you'll build a fully functional autonomous AI agent from scratch, using roughly 50 lines of raw Python. To follow along, you only need 3 things: a basic Python installation, a code editor, and an API key from OpenAI, or a local Llama instance. We are going to build our agent by following this roadmap. An AI agent is a large language model, plus a system prompt, tools, memory, and a reasoning strategy. Every piece of that equation maps directly to the code we are about to write. The LLM is the brain processing the data. The prompt gives it an identity. Tools give it hands to work with external systems. Memory tracks the state of the conversation, and reasoning provides a strategy to follow. When you understand how these 5 variables fit together, you gain total control over the AI's behavior without relying on pre-built enterprise frameworks. Step 1 is setting up the workspace. We initialize our LLM brain by passing in an API key and giving it a standard system prompt to define its core instructions. If we run this baseline code right now, it simply takes our prompt and returns standard text. At this stage, it is a standard chatbot. It cannot yet execute tasks. To give the agent hands, we write a basic Python function. This could be a file reader, a web scraper, or in our case, a calculator. But the language model cannot read raw Python code. In this split diagram, we translate our calculator function into a structured JSON schema, telling the model what inputs the tool requires. The schema names must perfectly match the internal Python function names. If there is a typo or a naming mismatch between the script and the schema, the language model will fail to trigger the tool. Computational tools are only useful if there is a precisely structured schema bridging the gap between natural language intent and executable code. Next, we need to handle the agent's state. Base language models suffer from amnesia between prompts. Every time you send a new message, they forget everything that was said previously. To fix this, we introduce a messages array. This acts as a continuous conversation history buffer. Instead of sending one prompt, we append each user prompt and system response to this array. A stateless request means the model sees only the current command. But by passing this multi-turn array with every call, the model retains memory of the entire interaction. Without this continuous state memory, the agent cannot execute multi-step plans because it forgets its own previous actions the moment they are completed. Now we assemble the strategy module using the REACT pattern, which stands for reason, act, and observe. This is the core logic loop of all AI agents. We wrap the LLM call in a continuous while-true loop. In the reasoning phase, we check for tool calls. If none are called, it breaks the loop, returning the answer. If requested, we execute the tool and capture the data. The most common failure point here is forgetting to append that new tool result back into the messages array before the loop restarts. If you omit that step, the agent never observes the tool's output. It assumes the tool hasn't run yet and requests it again, creating an infinite loop. This basic while loop is the fundamental control mechanism that elevates a static prediction model into an iterative problem solver. Now we test the agent. We present it with a complex math query that standard language models often struggle to calculate accurately on their own. When we hit run, you can watch the autonomous steps in the terminal. It identifies the need for the calculator, calls the tool, and receives the result back into its memory. Once it observes that data, it exits the loop and returns the final accurate answer. This 50-line script demonstrates the logic enterprise frameworks like LangChain or CrewAI use under the hood. From here, you can scale the project by integrating web search tools or building a secondary agent to verify the first one's work. Mastering these raw primitives shifts your role from a passive user of AI into a true architect of intelligent systems.